So hi friends, good morning. This is Reshma. Welcomes you to another session on database management system. So in this session, I'm going to discuss with you a very simple topic of relational algebra expressions. So that is aggregate functions and grouping. So now, as the name indicates, so aggregate function is a function which is used in simple statistical queries, and this function is used to summarize the information from the database tuples. This is used just for summarizing the information from the database tuples, and different aggregate functions available here are, so aggregate function sum to find the average, maximum to find minimum, to count the number of tuples available in the relational database. So these are the different aggregate functions we can use. So as a name, if we go for sum, the sum will be used to find the sum of the values of all the tuples. If I have a salary column in employee table, to know the total salary of the company database of the employee table, if I use sum aggregate function with the salary column, it will display the sum of all the salaries. To find average salary of the employees, we can use average. To find the maximum salary of the employee, we can use maximum. Then to find maximum salary, minimum salary from the employee table, I can use minimum. So then to count the number of employees working, I can use the aggregate function count. So then next we have grouping. So grouping attribute, the function is used for grouping the aggregate functions attribute wise. For example, I want to count the number of employees working in each department. So here grouping will be done based on department number, and count is aggregate function. So aggregate function used along with grouping attribute. Similarly, I want to find sum of salaries department wise. In department number 5, what is the total salary of the employee? Department number 4, what is the total salary? Section wise, I want to find maximum marks scored by the student. So here aggregate function can be used along with the grouping attribute to retrieve the data for a specific attribute. Attribute wise, grouping the attributes, and for each group applying the aggregate function. So as I said, grouping involves grouping the tuples in a relation by the value of some of their attributes. Department name wise, department ID wise, project number wise, employee wise projects handled, department wise projects conducted, location wise projects. So like this, grouping the tuples in a relation by value of their attributes, then applying the aggregate function to each group. So there the grouping function will be used. So here I have an example. To find average salary of employee within the department are the number of employees who work in that particular department. So here we'll see some example queries where we can apply aggregate and grouping attribute. So now to define aggregate operation, here we need to use the symbol this, and the symbol is pronounced as script F. So this is the script F function used to indicate aggregate function. So the syntax will be grouping attribute, aggregate function, function list. So here grouping attribute is name of the attribute, like department wise, employee wise, section wise, location wise, name wise, date wise, that is grouping attribute. Then aggregate function symbol, here function list may be counting the column, counting the tuples, or aggregating, like finding average, finding maximum, minimum, sum, average. So any of the function can be listed here for the particular relation. This is the syntax of grouping and aggregate functions. So now here grouping attribute, any attribute. Function list, the symbol will be name of the function followed by attribute. If I want to count, if I want to find sum of salary, function name is sum, attribute name is salary. If I want to count number of employees available, function name is count, attribute name is SSN. To find the average of the marks, function name is average, attribute name is marks. So like this we can make a list of functions. So in a single query we can write any number of aggregate functions. At the same time you can count number of employees in the department, sum of salary of the department, average number of average salary of the employee in the particular department. We can make a list of any number of aggregate functions, and here the attribute which is used for grouping. So this is about the notations. And again the result will contain group wise solution, department wise, department number 1, number of employees, maximum salary, minimum salary, average, whatever the function is. Again department number 2, department number 3, department wise also you can display, that is group by attribute followed by the aggregate function result. So for example, assume that I want to apply some grouping or aggregate functions on employee table here. So now here we have written a query to find average salary of the employee and counting the total number of employees. So if I go for this table, total employees are 1, 2, 3, 4, 5, 6, 7, 8. So just write grouping aggregate function symbol, that is script 5, function name count, attribute is SSN, count of SSN, it will count total number of tuples, total number of employees. Average of the salary, for all the employees it will add, find the average. So now here we are not given the grouping attribute, so this function aggregate function will be applied on the whole table. So total number of employees are 8 and average salary is 35,125. And here if I observe headings for the resultant table, so this is count underscore SSN and this is average underscore salary. So here I have not used any project function, project operator to display the headings, but implicitly the aggregate function, it has given rename the columns, because these columns are neither available in the employee table nor it is explicitly specified here. So this is done with the by implicitly by aggregate function. So how it will rename the columns of the resultant table? So the name of the column in the resultant table will be combination of aggregate function underscore attribute name. So here count underscore SSN is the first column name, average underscore salary will be column name for the second column. So like this it will combine aggregate function name underscore attribute as the column name for the resultant table. So but if you want to give another call, so if you want to give a new name, the any name which you prefer, then we can use the rename operator and we can give. So for example here I want to give the operator names like what I have done here, same counting the number of employees and average salary, but here I have used grouping attribute. Grouping attribute is department number, so it will count the number of employees in each department and average salary of the employee for each department. So department wise it will count the employees and display the average salary. So if I see the resultant table here for department number 5, see the result will contain the columns like, first it will display grouping attribute, which is a grouping attribute denum, it will be displayed, followed by aggregate function attributes. So now here if I see the name, it should display count underscore SSN, but it has not displayed count underscore SSN. It has displayed here number of employees. So why it has displayed number of employees? That we have done with the help of rename operator. Using rename operator, we have renamed the employee table name to table R. Table name is replaced by R. Employee becomes now R. Dnum, it is same. Second column is count underscore SSN, renamed to number of employees. Third column should be average underscore salary. So, but this has replaced by average underscore sal. So, like this, we can give a new name for the table and also the columns in the result of aggregate functions also. Remember here, if you are not using rename operator, the columns of the result after applying aggregate function will be the combination of aggregate function name underscore attribute of that particular function. Otherwise, we can rename according to our requirement. So this is how we can use aggregate function and the grouping attribute. So here I have another example. Just see here, the same example, but renaming is not done. So columns we can observe. This first is grouping attribute dnum, then count underscore SSN, average underscore salary. So then next topic is here recursive closure operations. After aggregate function, so in the same way you can apply any aggregate functions according to our requirement, whichever the data you want to retrieve by summing up or summarizing the tuples of the relation. We can take the help of these aggregate functions and we can retrieve the solution required data from the tables of relational database. So now, till now what we have done, we have applied these operations on two different tables. If we want to apply the operations on a single table, the same table has to be joined, that is the self join, or you can say recursive joining operation. So now here this recursive closure operation, this is applied to recursive relationship between tuples of the same type. For example, specifying the SSN of all employees directly supervised by employee whose name is James Borg. So here entity, the relation involved is employee. So first we have selected the details of Borg. What is the name here? James Borg. Then we have identified the social security number. So that is what I want to show here is on same relation employee. We are performing the joining operation and we are retrieving the data. This is from employee, this is from supervisor. Details of the same employee, where employee working as a worker, then other is also working as a supervisor. So this is how we can apply recursive closure operation on the tuples of same relation. Okay, so this is about aggregate functions in relational algebra. And by this we have completed almost all relational algebra operations in the current and previous sessions. So this is the table which summarizes all the relations or the relational algebra operations. So just for reference, you can go through this table which include all the relations like select, project and rename as union operation, union, set difference, intersection as set operations, then Cartesian product, then inner and outer join. In inner join, so we'll learn theta join, equijoin and natural join. In outer join, we'll learn left outer join, right outer and full outer join. So these are the operations which we have learned till now. Okay, in the next session, I'll discuss with you one more relational algebra operation, that is division operation. So if you have any doubts in the current session about the aggregate functions and how to use grouping attribute, please post your questions in the comment box. And in next topic video, I will discuss with you the division operation. To get the notification, please subscribe and click on the bell button.